Godot is beautiful, and if you're a Unity developer, this video is for you. We will focus on the engine and 4 key concepts in Godot that are really important, and trust me, this will make your life much easier. This video is going to be sort of like a mini course. It's lengthy, so feel free to follow along. Alright. Being a developer who has worked on a lot of engines like Unity, Unreal, and Construct for the past 6 years, Godot stands out to me as the best community driven engine. As painful as it is to learn a new game engine, we can make our lives a lot easier by understanding the basic fundamentals of the engine and applying it on our projects. Stick around until the end. Throughout this video, we'll take a look at some pretty cool features in Godot that you'd want to know. Before we get into that, if you're a Unity developer, I highly recommend downloading the .NET version of Godot because it has C# support. However, I recommend learning GDScript first, which is Godot's built-in programming language because most tutorials use it over C#. Once you make a couple of projects with GDScript and you're able to read GDScript from tutorials, you can then start using C#, and C# is pretty fast. When you create a project, make sure to check out the Asset Library tab. You'll be able to import community libraries directly onto your project. You can give the project a name and choose a folder. Then you hit on Create Folder to create the root directory of your project. For the renderer, you can start with any. Compatibility is best for older or low-end devices. Mobile is best for mobile games. And Forward Plus is great for desktop. You can change this later. Don't worry, just pick what you think works best. We can also choose version control metadata. If you choose Git, the project will include all the gitignore files and will be ready for version control using Git. We don't need it right now. Just to quickly describe the editor, this here is the workspace. You have 4 workspaces: 2D, which is useful for 2D level design and UI, 3D, which is useful for 3D games, obviously. Script is where we write our code, which will be in GDScript. If you want to write in C#, you will need a separate IDE like Visual Studio Code and asset library from which we'll be able to import community projects. On the left, you have file system, and this is where you'll be able to manage your project files. On top of that is the scene window, and this is similar to Unity's hierarchy, and you'll be able to populate your scene, but it's a little bit different. You also have the import tab to change the import settings of an asset. You can enable generate bitmaps or choose which type of compression you want, etc. On the right, you have the inspector, which is where you change the properties of objects in your scene, pretty similar to how it works in Unity as well. You also have this node tab, which we'll look at later in the video. On the bottom, you have other windows like the output, which is basically a terminal console. You have the animation tab, a shader editor, and so on. There are other windows available in Godot, and they will appear here automatically when we have the need to use them. On the top, you have icons to run the current scene or run the entire project from the very beginning. Alright, now let's have a look at the engine itself and how it actually works. There are 4 key concepts in Godot that you should have a good understanding of. Let's start with the most important one of all, nodes. Nodes are essentially the building blocks of a project. It is simply a basic entity that simulates a behavior in our game. In Godot, it is actually a bunch of nodes working together that makes our games come to life. Think of them like a single game object with only a single behavior to them. In Unity, we use game objects to create different elements in our scene, like characters, lights, and UI. Nodes here serve a similar purpose. They are the fundamental components that make up your game. When we start a scene, we have no nodes in them. We can add a node by going to the scene window and clicking on the Add Child Node button here. But a better approach would be to use the keyboard shortcut Ctrl+A. We can then select from a bunch of nodes that Godot provides. For example, we can search for a sprite 2D node, and then on the inspector, we can add a 2D sprite to render. Let me drag the default Godot icon for now. We can also choose rigid body 2D or 3D for physics simulation. We can look for basically anything. We have nodes for collision called collision shape, lights, audio, user interface, and so on. Let's go to scene, new scene. Let's choose a node of sprite 2D. This time, instead of manually creating a sprite node, we can go to the 2D workspace and simply drag and drop a texture from the file system onto the scene. And it automatically creates nodes for us. The same thing works for meshes as well. For meshes, it would create a mesh instance 3D node instead. We can select a node and then change the properties in the inspector as well. We can go to the node 3D section here and open the transform foldout and change things like the position, rotation, and scale. We can also add nodes as a child of another node. This organizes nodes in a hierarchical structure. This is a powerful way to structure our game's elements and make them work together. One good example is when you create a character, you can use the node character body 2D or 3D. This node will have all the basic character controller functionality built in. And then before you add a sprite or a mesh as a child, you can add something like a node 2D or node 3D and call it pivot, and then you add the sprite or the mesh. This way you can easily perform operations like rotation very easily by simply rotating the pivot instead of the sprite. This won't mess with the animations. The best part about nodes is that we can attach a script to them to further tweak its behavior. We use scripts to handle the logic. We can handle the input and move the player, use AI to navigate the enemies, spawn objects across various intervals, and so on. We create a script like this. Click on a node and then click on the attach script button. You'd only need one script per node. We will look at scripting in GDScript later in the video. Ultimately, in Godot, nodes are everything. The second key concept in Godot are scenes. If nodes are the building blocks of your project, then scenes are the actual buildings. A scene in Godot is an asset, which is basically a collection of nodes. We will always be working on a scene. If you have worked on Unity, a scene can be considered as the combination of a scene file and game objects and the concept of prefabs all squished into one single thing. Like I said before, a scene is an asset. It is a file in a file system which we can reuse anytime we want on other scenes. They are simply containers that hold nodes. And the best part is that they can be used as nodes themselves. For example, we can create a scene by going to Scene, New Scene. Let's choose a 2D scene node. Let's save it and call it Level. We can also create a new scene, again by going to Scene, New Scene, or by using the keyboard shortcut Ctrl+N. Let's add a rigid body 3D and then a child node of mesh instance 3D. We can go to the inspector and click on the mesh property and create a new cylinder mesh. Let's save this temporarily as the player. And now we can go to the level scene and then add an instance of the player scene by clicking on the instantiate child scene button or pressing Ctrl+Shift+A and then choosing the player scene. Or we can simply drag and drop the player scene from the file system into the viewport. We can go back to the player scene by clicking on this icon here and then let's make some changes. Let's add a material by going to the mesh, and a mesh is a resource, which means it's something made inside Godot, and we can change the properties of that resource by clicking on it in the inspector. And for the mesh, we can create another resource, a material, and then change the color by going to the albedo section. Let's change this into something like pink. If we save the scene and go back to the level scene, the changes do get reflected. Scenes are basically like prefabs. This is important as it dictates the workflow. We create a scene for the level. We also create scenes for the player, enemies, and elements in our game. And we put them all together in the level scene, and they would work together. The advantage of scenes approach is that we can run individual scenes separately in Godot. For example, we can test and check if the player works properly by running the player, which is a separate scene. Maybe perhaps add a few platforms and we don't have to open the level scene. This is really useful when you have version control. This may reduce the chances of having merge conflicts. Next up is the scene tree. The scene tree is simply the hierarchy of nodes in a scene. This is a simple but important concept to be aware of, and this is especially useful while coding. First, let us get the picture clear. Imagine a 2D platformer game. In the scene tree, we can see the root node, which typically represents the entire scene. Beneath it would be the player, character, enemies, platforms, and everything else. This really helps in managing and organizing various elements in our game. It keeps track of nodes and their relationships in our game. Nodes are processed in a specific order in the scene tree. For example, nodes that have physics calculations are processed before nodes that does rendering. Nodes can also be added, removed, and retrieved dynamically or in-game with the help of the scene tree. But a crucial factor here is that the scene tree is actually a class, which means that we can do stuff like pause all nodes or pause the game, switch between scenes, aka switching levels, very easily. We can also use the scene tree to organize our nodes into groups. Groups are equivalent to tags in Unity. We can group a bunch of nodes into a single group, and we can use the scene tree and access all the nodes in the group and iterate through them or call methods on them. Simple. But this is the most important bit. According to Godot's official docs, the scene tree is the default main loop implementation used by scenes and is thus in charge of the game loop. So the scene tree is in charge of running the game, and if we have an instance of a scene inside a scene, we are basically copying a scene and putting all the nodes there, and it creates a small branch in our tree. We can confirm this by running our scene, head outside to the engine itself, and go to remote. This is like a live scene view in Unity, and we can open up this scene tree and see all the child nodes established. Cool. And before we get to the final important concept, we need to know how to script in Godot. This requires a dedicated video, so let me know if you want something like that. But to make it short, we can add a script to a node. Because of how nodes work and the fact that we can access the scene tree anytime within a node, we pretty much only need a single script per node. Let's create a new scene for the player, and let's drag the Godot icon for now as the sprite. Note, Godot automatically creates a sprite 2D node for you. Let's adjust the transform properties to set the position to 0, 0. Let's rename the icon node to player sprite and then attach a script to it. We can then choose the language here. For now, we'll go with GDScript. We'll be creating a class, and by default, it will be inheriting from the same class as of the node. In this case, sprite2D. This makes sure that we can access all sprite2D properties of this node. You'd usually want this to be of the same class. Let's click on Template, Node Default, and choose the name and location for the script and hit enter. We will be teleported to the script workspace. In the script, we can see that we extend from sprite2D. Extends is the keyword used to imply class inheritance. Because GDScripts looks very similar to Python, we don't have any curly brackets here, and the indentation actually matters. We have two funcs or functions. Ready is equivalent to start function in Unity. It gets called when an instance of the script gets created. In this case, when the player is spawned. We also have a func process which has a parameter delta. This is similar to the update function, and this is called every frame as long as the node which contains the script is active. Delta is the Godot equivalent of time.deltaTime and is essentially the dynamic time interval between each frame. Okay, let's make the player move on input. First, we need to create an input map. We go to Project, Project Settings, Input Map. This is equivalent to Unity's input system, but I think it is better because it is fully functional and built in. We need to create 4 actions. Let's call it move left, move right, move up, and move down. Let's bind some input events to these actions by selecting an action and clicking on the add event icon over here. Now Godot will be listening for input. Let's press the left arrow on the keyboard and press OK. Let's also assign the remaining arrow keys to the remaining actions. Because this is standardized and very well made, we can add multiple input events to a single action. We can add the WASD keys to these 4 actions as well. Now, what this does is, whenever we activate these input events, in this case, when we press these assigned keys on the keyboard, the corresponding action will get triggered. This is how we check for input. Okay? Back on the script, we should create a vector2 which stores the current velocity of the player. So we say var velocity. Remember, no semicolons. We don't need to specify it as a vector2. The computer will detect it during compile time as long as we assign a vector2 value to this variable. This is applicable to all variables. Now inside process, we first set the velocity to 0. To be clear, it's vector2.0. Then we write if input.isActionPressed, and this function will take in a string, and we will get prompted all input actions we have created and some other ones Godot has already made for us. Let's choose move right, and instead of curly brackets we use a colon, and Godot will automatically add the indentation. Now if this action is pressed, we set velocity.x plus equals 1. Similarly for the left, we set velocity.x minus equals 1. For up, velocity.y minus equals 1. For down, velocity.y plus equals 1. We use plus equals and minus equals because this negates the effect of the opposite action if they are pressed simultaneously. Also, the y-axis is inverted in Godot, which means the up is negative y and down is positive y. It could be confusing at first. Before we move the player, we need some sort of speed. Let's create a new variable where speed equals 0.0. We use the decimal here to specify it is a float and not an integer. But this is not ideal. We want the power to make this editable in the inspector, right? To do that, simply add @export before the var and we are good to go. So exporting a variable will make it visible in the inspector. Next, we check if velocity.length is greater than 0, or in other words, if we get any input, we set velocity equals velocity.normalized multiplied by speed. And outside the if condition, we say position, which is the position property in the transform field, plus equals velocity multiplied by delta. This is basic translation. Make sure to save the script, select the player scene, change the speed to let's say 500 and hit run current scene. And the player moves. However, this is just the player scene. To actually make a level, let's create a new scene, and for a new level I always recommend starting with the root node of node. Node doesn't contain any transform, it's just simply an empty container, which is useful for creating scenes for levels. Or we can create a 2D or 3D scenes as well. Let's save this scene as level. Let's instantiate a child scene and select the player scene. Let's play the scene. Alright, to move the player to the center of the screen, let's add a new node of type marker 2D. Make sure it is not a child of the player. Let's call it start position and move it to somewhere near the center of the camera. Now, let's go back to the player and make a new function called start. And in this function, we could do stuff like set the start position, reset the health, etc. And let's add a parameter called start pause. And let's set position equals start pause. Now back in the level, we create a script for the level and say on ready, we need to get the player and call the start function. There are different ways to do this. The simplest method would be to use the scene tree that we talked about earlier. We simply need to write the function getNode and then specify the name of the node we want to get. Let's choose player sprite. In fact, let's rename it to player and change it here as well. So we say player.start getNode start position.position. And getNode is very similar to getComponent in Unity. It literally gets the node. But we can shorten this by simply using the dollar symbol. $player.start $startPosition.position. This does the same thing, but it's much more readable. We don't need double quotes for $player here because it is a single word. Start position contains a space character in between. Therefore, it requires double quotes. Let's run the scene, and it works. Now that we are a little bit comfy with code, let's discuss the final thing for today. Signals. Signals are simply how Godot Engine implements the observer pattern on its nodes. Whoa, what am I talking about? The observer pattern is a programming pattern that introduces the concept of a speaker and observers. It's like a radio or this YouTube channel. Whenever you, a listener or an observer, hit that subscribe button below, you will get notified on your subscription feed whenever I, the speaker, uploads a new video. So in Godot, whenever something happens, for example a collision or when an object goes off camera, a signal gets emitted. Signals are simply like delegates in C#. we can subscribe or, in Godot terms, connect any function inside our script to a signal. And when the signal gets emitted, either automatically or even manually through code, all of the functions that are connected to this signal across multiple nodes in the level scene tree gets called. This is so useful as it reduces a lot of dependencies. Let's say we have a signal that detects collisions of the player. In fact, let's do that very quick. Let's create some enemies, create a new scene, and we will start with the root node called area 2D. Why area 2D? Because enemies, if you think about it, is actually an empty area with an animated sprite as a child. The main logic happens on collisions with the player, depending on the game, of course. So it should be an area 2D. This gives us an error which says we need a collision shape 2D or collision polygon 2D. Let's create a collision shape 2D child node. And in the 2D view, let's add the Godot icon again for the enemy. If we want to animate this, we need to choose an animated sprite 2D node instead. To change the color of the sprite, go to visibility, modulate, or self-modulate. Modulate changes the color of this sprite and all the child nodes. Self-modulate changes only the color of this node and not the child nodes. Let's choose self-modulate. The best way to pick a color is to go to HSV, set S or saturation to full, change the hue and choose a value. This actually looks pretty cool. The collision shape still shows an error. We need to specify a shape for the shape. So select the node on the inspector, click on shape where it says empty, and we can create something called a resource. Resources, like I said before, are stuff that we make inside Godot. For this example, let's choose a rectangle. Choose the shape that best resembles your sprite. Let's change its size to fit the sprite. You can also use collision polygon 2D as well for custom shapes. Let's create a new script for the enemy. Let's go back to the player now, but we now know that we made a mistake. The root should be an area, right? No worries, let's add an area 2D node. We can simply right click, make scene root. Let's rename it to player. Now we just need to create a new script and copy paste the previous script into this, except for the extends part. So this is really important. Sprites or mesh nodes don't generally get used as root nodes. You may get some errors, especially if you're dealing with sprite stuff in code, but you can solve most of it by using the dollar symbol and getting the child node. Let's detach the script from here. Let's also delete the old script from the project as well. Add a collision shape 2D, create a rectangle shape, and adjust the size. Let's put this on top of the sprite. Because we created a new script, make sure to set the speed back to 500. And we are right back. Now, for the most important part, we go to the player scene. Let's click on root node and head over to the node tab. We have signals and groups. Let's go to signals and we can see all the signals Godot has created for us. Let's choose area entered. We can read when each one gets emitted by hovering over them. This will emit a signal when another area enters this area. Let's double click. This pops up a window which lets us create a function inside the script on any one of the nodes in our current scene and connect that function to this signal. We can rename the function here as well. We generally leave this at default and click connect. This creates a new function in our script called onAreaEntered, and now on the nodes tab, we can see that the function is connected. We can also see a green icon close to the function to confirm that a connection is made, and we can click on it to see the details. Inside this function, let's just print hit for now, and print function just prints to the debugger window in Godot. Let's go back to the level scene and drag and drop a bunch of enemies. Let's hit run, and now we can see that the player is indeed calling the function whenever it hits a new area 2D. We can now call the damage function here as well. This is pretty cool. This reduces the player having to be dependent on anything. The player doesn't care what it collides with in this case. But how do we check for certain that it is indeed the enemy that it is colliding with? There could be a number of colliders in the level, right? How could we do that? We do that with groups. Groups are equivalent to tags in Unity. We can group together multiple scenes to a single group and check if an area belongs to a particular group. Let's go to the enemy scene and create a group called enemies. This automatically adds it to the group as well. To double check, if we go back to the player, we can see that it is not in the enemies group. Let's go back to the enemy. Note, this only adds the root node to the group. If we want to add the child nodes as well, click on manage groups and we can add and remove child nodes from the group. Now if we go to the function and check if area.isInGroup enemies print hit, and this will filter out enemies. To add health, let's create a new variable for health and set it to 5. Now we call a damage function on enemy hit. Let's create that function and decrement health by 1. Let's rename the enemy scene to enemy1 and an error comes. I wanted to show this deliberately because we have some issues renaming things. And this is because whenever you rename any resource, just close all tabs inside Godot. This makes sure that all placeholders are reloaded every time we open a scene. Now let's set this to enemy1. Let's duplicate it, call it enemy2. Open enemy2 and change the icon modulate color to something else. Save it. Now we have multiple enemy types. Let's go to the level, add some enemy2 and hit F6 or run scene. And it works as expected because both enemy1 and enemy2 are assigned to the same group. Let's double check that by removing the group from enemy1 and we can see that hit doesn't get printed for enemy1 anymore. Let's revert that. We can also make signals of our own. Let's do that by creating a simple UI. Let's create a new scene. Let's add a root node called canvas layer. This is a basic UI canvas. Let's rename it to HUD. We'll add a simple hit point setup. UI text nodes are called labels in Godot. Let's add a new label, call it HP. On the inspector, let's set the text to 3 for now. To set the position, there are anchor presets available. Let's click on this button here and choose this one. This will change the anchor point of the text and will position it exactly at that point. This makes sure that our UI element stays in position when the size of the game window is changed while the game is being played. We need to import font files into the projects to change the font theme. But for now, let's go to theme overrides, font sizes, and check this button here and set the font size to something like 50. Let's go back to the level, add a scene instance of type HUD, and we can see the text in our game. By the way, if we want the player to be drawn on top of other sprites, go to the player scene and change the Z index in the ordering panel. Higher Z index means it will render on top of everything else. Cool. Back on the player script, let's create a signal called player damaged. Note, the S in signal is lowercase and on area entered, we write player damaged.emit. Let's pass in the health as an argument. This will call all functions connected to the signal. On the node tab, we can see our new signal. Now on the HUD scene, let's create a new script. Let's create a new function called setHealth, which takes in a health. We don't need to specify it as an integer or anything. And then say $hp.text equals str of health. And str is a useful function that converts anything to string. Now this is important. We want to connect the HUD to the player. The only place where they both exist is in the level. Let's go to the level scene and click on the player instance. Double click on our signal and instead of connecting it to the node, we select HUD and then hit connect. This will create a function for us in the HUD script. Try not to get confused here. This is the HUD.gd script file and not the level script. We are in the level scene. Make sure to add our parameter health and say set health health. Now every time the player gets damaged, the label gets updated. One final thing is to go to the level script and after we set the player start position, we say $HUD.setHealth$player.health. This simply sets the text to whatever the player's health is in the beginning. In our case, it is 5. And yay, everything works as expected. Now, let's duplicate this level scene, call it level template. We do this because this makes creating new levels easy. We don't have to reconnect signals and references whenever we create a new level. We can just duplicate this template and all references are intact. I don't recommend using the entire thing as a scene instance because we lose the ability to use the dollar symbol and it's a lot more difficult to get the nodes that way. There is probably a better way to do this. Let me know in the comments if you know of anything. Okay, here's some bonus tips for making it this far. To create references of other nodes in script, we say at export var variable name, call it HUD, and then a colon, and then the class name. Let's try using canvas layer. Now if we go to the level, we can drag and drop our HUD into this, but not our player because the HUD actually has a root node of canvas layer. To get a scene, let's say to spawn an enemy, we'll create a new at export where enemy scene packed scene. We can now drag and drop a scene from the file system. Another tip, there's actually a timer node inside Godot which makes things so easy. Let's quickly add it to the level. Call it spawn interval. We can change the wait time to our liking. To enable it on start, check auto start. Head over to signals and connect timeout to a new function in our level script. Let's connect it to node, and on timer timeout, we spawn the enemy. We do that by saying enemy scene.instantiate, but we need to modify the position of the spawned enemies. To do that, let's save the spawned instance to a new variable enemy. Back on the level, let's create 4 spawn positions. We do that by creating a marker 2D node and then duplicate it 3 times. Let's go to the 2D workspace, set this to the 4 sides of the camera. Now we need some sort of array, right? Now there is a whole concept of dynamic arrays in Godot, which stores multiple data types in a single array. But let's stick to the basics. There is no actual arrays in Godot. They work like lists and we can index into it. To create an array, we use the class array. Array is actually a class here, just like packed scene or canvas layer or anything in green. And we can create an object of a class just like how we did it for the enemy scene. We say at export var spawn points colon array angular brackets, and to specify the type of the array, we say marker 2D. Let's go to the level. We can click on this array, set the size to 4 and drag and drop our spawn points. Now we need to get a random spawn point from this array, which means we need a random index, and the way we do that is with the randi function. This function actually returns a random integer between 0 and 4 billion something. So if we use the modulus operator and get the remainder by dividing that random number with the size of this array, we will get a random index. Does that make sense? If the size is 4, using the modulus operator always gives us an integer between 0 and 3. We can get a random position by using this index. Then say enemy.position equals random position. And big tip that I always forget, whenever you spawn nodes, you always need to call the function add child and pass in the node. This makes sure that the spawned instance gets added to the scene tree. Just to make the enemies move, we create variables for velocity and speed. Let's create a function setTarget which takes in a target position, and we set the velocity to be target position minus position dot normalized multiplied by speed. The former will give us the direction towards the target, and multiplying with speed will make the velocity. Inside process, we'll set position plus equals velocity multiplied by delta. This will move the body based on the velocity. Just for fun, we can also say look at target position. This rotates the object so that it points towards the target. Now back on the level, before we call add child, we call this function and set the player as the target. Let's test everything out. Let us delete all of these enemies. And we have something like a game. And that's it. We have sort of created this weird game, but more importantly, we have tried our best to learn these important concepts inside Godot. Nodes, scenes, scene tree, and signals. And we learned a lot of cool stuff along the way. Hope you found this mini course useful. Let me know if you need more Godot content, and take care. See ya. Bye bye. If you don't know, this is a reference to my very first video.